In this video, we are going to talk about the hyperbola. A hyperbola is a collection of all points in the plane, the difference of whose distances from two fixed points called foci is a constant. So when we see a hyperbola, we're going to see something that looks like this. It's going to have two pieces to it. They look kind of like parabolas, but they're not. They're going to come in pairs. And we're going to have this thing called a transverse axis. The transverse axis is going to go through the foci, and it's going to go through the vertices, and it's going to go through the center. So notice with this that the center is actually between the two vertices. And then we have this conjugate axis that's going to be perpendicular to the transverse axis. And then we can create these asymptotes, which will help us draw a picture. And the asymptotes are going to cross through the center like this. So if we know the asymptotes and we know where the center is and we know where the vertices are, we can draw a quick sketch because we know that the graph is going to ride the asymptotes out to infinity and negative infinity. So what are my forms here? So let's look at our forms for a hyperbola. If you're creating a cheat sheet for a test quiz or final exam, this is something I would write on those. So our center is always going to be at HK. Remember, the center is going to be in between the two vertices. It's not actually going to be a point on the graph, but it gives us a starting point. So we're going to have hyperbolas that open with the transverse axis parallel to the x-axis, which means it's going to open left right. So it's going to look something like this when we graph it. And then we're going to have hyperbolas where the transverse axis is going to be parallel to the y-axis, which means it's going to open up or down. So it's going to look like this as the two pieces. So once we find the center, we can find the vertices if we know what A is. Okay, notice A is always underneath the first term, and then our B is always underneath the second term. So A gives us the distance from the center to the vertex. We need to know B also so that we can find C. So B squared equals C squared minus A squared here. And we can find C by moving that A squared to the other side. And C is going to be the distance from the center to the foci. Remember, foci are going to live inside of the openings there. So the foci, here's my opening. Foci is going to be inside. Here's the other opening. Foci is going to be inside. Really similar to what we saw with quadratics and parabolas. Asymptotes, we're going to have y minus k, with k being the y-coordinate of the center, is equal to plus or minus. Notice our slope here is the ratio of b over a if this is going to open left-right. And then parentheses x minus h. So we're using that center there, and we're using b and a to figure out the slope. Whereas if it opens up down, that slope's going to change a little bit. It's going to be a over b. All right, so let's look at a few examples. So we're going to start with number 50. So notice the form. We got a y term first, and that tells us how this is going to open. It's going to open up or down. So we're doing that comparison there. Let's find the center. So the center is going to be at HK. And in this case, the center is going to be at 2, -3. Remember, H is what's connected to the X, and K is what's connected to the Y. We would think of this as a minus -3 there. We need to find vertices. So let's start by identifying A and B. So A is going to be under that first term, which is going to be 2. Remember, this guy's quantity A squared. B is going to be 3, because this is supposed to be B squared. So I would take the square root. And we're going to need C, so let's go ahead and figure that out. We know C squared is equal to B squared plus A squared. So C squared is equal to 3 squared plus 2 squared, which is 9 plus 4, which is 13. So C is equal to the square root of 13. So we've got some pieces going on here. We need to find vertices, foci, and then asymptotes. And then we'd be able to draw a quick sketch. So remember, the vertices have to live inside of the two pieces. Well, the vertices are going to be right here. Sorry, let me think about that. So, and the center is right here. So if we think about how we're going to get from here to here, that's where that A value comes in. It's going to move a distance of A. And then same here, it's going to move a distance of A. So if we think about how are we going to get from the center to the vertex? The center is at 2, -3. What's happening is I'm moving up and down here. So I'm going to take my vertex and I'm going to add and subtract my A value, which my A value is 2. So my vertices are going to happen at 2, -3 plus 2, which is -1. And then 2, -3 minus 2, which is -5. Foci is going to work the same way. It's going to live inside of these pieces, and that distance from the center to the focus is C. Same thing here. The focus would be down here. Center to the focus would be C. So my center is at 2, -3, but I'm going to take that y coordinate and I'm going to change it by square root of 3. So I'm going to add and subtract square root of 13 to it. So that's going to give me my two foci. 2, -3 plus square root of 13. And then 2, -3 minus square root of 13. Okay, now let's look at asymptotes. So if we want to find the asymptotes for this guy, we can use this form right here. Y minus k equals plus or minus a over b times x minus h. And we have all the pieces to do that. So h and k is coming from the center. So we're going to have y minus -3 equals plus or minus a over b times x minus h. Our h is 2. I'm going to clean that up a little bit. Y plus 3 equals plus or minus 2/3 x minus 2. So we've got two equations that's coming from that, and I'm going to write those both in slope-intercept form. So y plus 3 equals 2/3 times x minus 2, and y plus 3 equals -2/3 times x minus 2. Do some distributing. Subtract 3 from both sides. So y equals 2/3 x. So we have -4/3 minus 3, which is -9/3. And that's going to be a -13/3. Here, distribute. So this is going to become a positive 4/3. So notice we're going to have a positive slope and a negative slope. And that's going to happen with both of them. Both of the asymptotes. So we're going to subtract 3 from both sides. So we have 4 over 3 minus 3, which is 9 over 3. 4 over 3 minus 9 over 3 is a minus 5 over 3. So there's our two pieces. So if we wanted a quick sketch of what this would look like, I draw my Cartesian plane. So I'm going to start by drawing these guys. And I'm in the center because we know they're going to cross in the center. So it centers at 2, negative 3. And I'm actually going to cheat and find a better way to do this because we know something about these slopes and we know something about these asymptotes. The asymptotes have to pass through this point. I know one has a positive slope of 2/3. So if it has to go through this point and I need to graph it, I can just find another point that lives on that graph. And then I can connect those dots. Asymptotes are always going to be with a dotted line. And then I need to graph this one. So I'm going to use the same idea. Slope is negative 2/3, so I'm going to go down 2 and over 3. So there's my axis. Now we could use the slope-intercept form. We could say this has a y-intercept of negative 5/3, and then we're going to go down 2 and over 3 from that. But you can actually use any point on that graph and then the slope to find the equation of that one. So we've got the center. Now we need to find the vertices. The vertices are at 2, negative 1. So 2, negative 1, and then at 2, negative 5. And remember, this is going to ride the graph out to infinity, so a quick sketch is going to look something like this. If I wanted to graph these guys, the vertices, the foci, I'm going to need a decimal approximation for that. So I'm just going to plug that into the calculator. So what is negative 3 plus square root of 13? Using my calculator off screen. So this point is 2.61, and then negative 3 minus square root of 13. This is at 2, negative 6.61. So 2.61 would be somewhere around here. 2, negative 6.61 would be somewhere around here. So there's our quick sketch of that.